Alright, so we're going to do some rational exponent stuff. There's going to be quite a bit of fractions in this, so hopefully it does not scare you away. It's honestly not that scary. It's just like the other stuff that we have been learning, it's remembering our rules. So for this, for any real number b and any positive integer, b to the power 1 over n is going to be like this. It's going to be the root of n, b, except when b is less than 0 and n is even, when b is less than 0 and n is even, a complex root may exist. That sounds like a lot of words that you probably don't understand, but it's okay because I'm going to explain it as we're going along, okay? So these are just some examples of what they're talking about. For this 27 to the power 1/3, when it is to the power 1/3, that just means it's the same exact thing as a cube root. To the third power is the same exact thing as a cube root. So let's see. This is the cube root of 27. So where did this stuff come into play? B to the power 1 over n equals the nth root of b. So 1/3 is the third root. How I always remember it, because you're going to start seeing some stuff where it's not just like 1/3, it might be 2/3 or it might be 4/5 or something like that. How I remember it is top on inside, bottom on outside. This is 27 to the power 1, and then on the outside you have your 3. Okay? You know what I'm saying?
Yes.
Okay. So for this one, to the power 1/2 is the same thing as saying square root. Square root negative 16. But what did we learn in quadratic formula? What can you not have under a radical? A negative. So whenever we were talking about negative numbers, what happened when you had a negative underneath the radical? What do you have to pull out? It's an I, right? So this is I square root 16. Okay? And what's the square root of 16? 4. So 4i. That's what this is talking about. When b is less than 0, our b was less than 0 because it was a negative number. Okay? So that's less than 0. And our n is even. Is your n even? Yes, your n is 2. A complex root may exist. All complex means is you have imaginary numbers in there. So did we have an imaginary number?
Yeah.
Yes. Do you see what we're doing?
Yeah.
Okay? These are the simple problems, okay?
So that's simplified.
So this is, with this, it's not really simplifying, it's taking rational exponents, you're taking it from exponent form to radical form. And then we're going to take it from radical form, and we're going to put it into exponent form. So you're going in between two ways. You know what I'm saying? So we're going back and forth. So write x to the power 1/6 in radical form. An easy way to remember it, exponential form, what's the key word in that? Exponent. So you know that that's going to be, it has to have an exponent up there. Radical form, what's your key word? Radical. So you want it to look like a radical. You have to have a radical in it. So since we're doing top on inside, bottom on outside, we have the 6th root of x to the power 1, which is just x. And let me recalibrate my board really quick, because this is so this is in radical form. Good?
Yes.
So this is where I said that it gets a little bit different, because what we've seen so far is when you have a 1 on the top.
What was that thing, the final form for?
That was the final form. That was switching into radical form. But this is when it gets a little bit different, because now you have a 7 on the top. So that rule, top on inside, bottom on outside, comes into play. So you're going to have the 4th root of d to the power 7. Now you guys are my honors kids, and I know what you're thinking in your head. What are you about to say?
How many times can 7?
Okay. So that's it. I knew exactly where you were going to go with that. He saw immediately you have to have 4 of something to bring a d out. And I agree with you, but we're not simplifying right now, okay? All we're doing is writing it in a radical form. So this to this, boom, you're done. Answer correct on the test. That's it. You're not simplifying. I didn't ask you to simplify. Don't go too far. If I tell you to go from exponential form and turn it into radical form, this is where you're going and you're stopping. You're not taking anything out.
Okay.
Are you
Okay.
ever gonna add to simplify?
Huh?
Are you ever gonna add to simplify?
Yes, I will. Yes, I will. However, look, this is what I'm going to say because I don't want you to get too kinds of crazy and get confused. You aren't going to pull anything out. However, because this will happen. If I were to tell you, let me think of one that will work. Okay, so say it was, I'm just making up a problem. D squared to the power 7 over 4, okay? Because this is a possible problem, okay?
Yes.
Say that you have this. Top on inside, bottom on outside.
Would you add it?
Okay? Just wait with me.
I can do this.
You do the same thing. Top on inside, bottom on outside. This is the 4th root of D squared to the power 7. Now, I don't want you to simplify, no, like I don't want you to simplify your radical and take anything out. However, I do want you to simplify if it's under your radical. This is a power to a power. So go back to math 1. What was the rule for power to a power?
Do that.
That's power times power.
Oh, subtract.
Nope, that's the quotient.
Multiply.
What'd you say?
Most of it.
It's multiply. We need to get those rules down. I gave you the song,
Yeah.
so make sure you memorize those. So you multiply. So this
14.
would be radical form for this problem.
Okay.
We don't simplify it to the point where we're taking our d's out. You just make it where the inside is simplified. And I want you to star this problem because I'm giving you one like that on the test.
Question.
Okay? So I want you to star one. What's up?
Are we gonna have to do that only because of
Can you list
parentheses?
it after?
Are you going to have to do that one?
If it's in parentheses,
What do you mean?
like D squared, and then to the second power.
Yes, you will. Because that's telling you this is a power and it's raised to another power. So you have to use the power to a power rule.
Caesar, can you
Yes,
list it out?
Yes, ma'am. Do we see what we did there?
Yes.
Do you see how I went from that?
Yes.
That was our problem. You good, Isla?
Yeah.
Alright, so now I want to try this one. I'm going to start off with the harder one because then I want you guys to come back in and we're going to try this other one and see if
Is
you
that
got it.
negative?
So for this, we want to write it in exponential form. So we want to make it where it has an exponent. Top on inside, bottom on outside. All you do for this problem
3.
is we've got z. The top is on the inside, so -5. The bottom is on the outside, so 3.
Oh, so what happened to the square? Oh, what's the square?
There isn't squared, it's a cube. Finish. That's
I
it.
put 3 over there.
Easy so far?
Yes.
Can you guys try this one by yourself?
Go up, go back.
Sorry. Y'all know I get ahead of myself sometimes.
Yeah, okay, you got it.
Good? Mm-hmm. Alright, so let's see if you can try this one.
What's that over there thing? Let me trick you.
I don't know why it's been doing that the past couple times. It hasn't been lining up. have the right answer? Or check YouTube?
Yes.
Good?
Yes.
What'd you get?
Z 104.
Z to the power 104. We had top on inside, bottom on outside. What's the top technically? 1. So top on inside, or top on the inside, and your bottom is on the outside. Z to the power 1/4. Perfect. All right. Moving on. Now we're going to evaluate an expression. So this is about evaluating expressions with radical or with fractional exponents.
You explain and you do the concepts.
Hmm?
You can explain it or do the concepts.
Yeah, I don't expect you to know how to do this yet, so I'll explain it to you. Do you want to know the rules for simplifying before or after?
Or
Usually I give them to you after, but I'll give you the option. Okay. So I want you to write down these rules. This is how you know, okay? So you asked me last time, well, how do we know when we're fully done? Well, for these problems, this is the list that has to be fully completed to know that you are completely done with solving this, okay? So an expression with rational exponents is simplified when all of the following conditions are met. For one, you cannot have any exponents anywhere. Not on the top, not on the bottom, anywhere. I'll explain to you in a couple of minutes how you get rid of those negative exponents. It has no exponents that are not positive integers in the denominator. So what does that mean? You cannot have fractions on the bottom of your fraction. So no fractions on the bottom. You can have them on the top, you cannot have them on the bottom. So none in the denominator. It is not a complex fraction. So that means there's no negative numbers under your radical. Okay? And then last but not least, the index of any remaining is the least number possible. So that just means the number under your radical cannot be simplified anymore. You've done your factor tree, you saw if you can take everything out, you can't go any further. Also, all of your fractions have been simplified. So if you had a 4 on the top and an 8 on the bottom, you've simplified that to 1/2. conditions, there has to be met. What's the first thing that stands out to you?
80.
Huh?
Negative sign.
The negative. That was the first thing that stood out to me, was there's a negative there, okay? And you can't have a negative anywhere. So the rule is if you have a negative on the top of a fraction, you bring it to the bottom. And if you have a negative on the bottom of the fraction, you take it to the top. This isn't a fraction, but can we make it one?
Yes.
Yes. So we're going to take and we're going to bring this 81 to the power 1/4 to the bottom, which is going to leave what on the top?
Negative.
We're taking the 81 to the power 1/4, we're bringing it to the bottom, it turns it positive, and what has to be left on the top? 1.
Okay.
Okay?
Yes.
Would you like the reciprocal, basically?
It's not really the reciprocal, you're just taking and bringing it to the bottom, because you can't have a negative exponent, so that's the rule, is you take it to the bottom if it's on the top, and then you're left with a 1 up at the top, because you can't be left with 0.
Oh, yeah.
So you're left with 1, because 1 times anything will give you
So
itself.
what if it's 2?
If it was 2 where?
It was negative 2. That was negative.
Is it here?
Yes.
So if it was 81 to the power negative 2 over 4, well that would simplify to negative 1/2, so it wouldn't be that. But if it was like negative 2/3,
Yeah.
you'd bring it down and it'd be positive 2/3.
Okay.
Okay? Let me ask you something off the top of your head. Do you know what 81 to the power 1/4 is?
No.
Me neither. Okay? So you gotta try to figure out how we're going to get that to simplify, because we are not going to use a calculator. No. No. Do it without a calculator. Okay?
Well,
Can I do 2 to the power anything and get 81?
no.
No. It's impossible. Can I do 3 to the power of anything and get 81? What?
Hold on.
3 to the power. Okay, let's go through. 3 to the power 2 is what?
6.
4.
No. What's 3 squared mean? 3 times 3.
No.
So that's 9. So what's 3 cubed?
The 3 is 27.
27. So that's not it. What's 3 to the power 4? 81. So we're going to turn 81 into 3 to the power 4. So 1 over 3 to the power 4. That is the same exact thing as 81. 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is 81. And this is to the power 1/4. What do you know about those rules? What rule is this? Power to a power, so what do? What's 4 times 1/4? 1. So this is 1 over 3 to the power 1. What's 3 to the power 1? So what's your answer? 1/3. Look at that. Wasn't so bad.
No. So we're done?
How do we know that this is the end? Okay, well look at what your rules were. Does it have negative exponents? No. Are there any exponents that aren't positive integers on the bottom? What's the integer, or what's the exponent here?
1.
The exponent's 1. That's a positive integer. It's not a complex fraction. Do you see any negative numbers under a radical? No? The index of any remaining radical is the least number possible. You don't even got a radical in there anymore. Okay? So we've reduced it all the way. You can't reduce 1/3. You're finished. Good? Alright, let's do this next one. So I have 216 to the power 2/3. Do you know how to do that in your head?
Yeah.
Do you? I don't. Do you know of anything that could be like squared or cubed that's going to give you 216? There's one that I have memorized before. I'm making you think a little bit more deep.
6.
6 to the power what?
6.
No. 6 times 6 is? 36 times 6 is? 216. Great job. So he just told me 6 what? 6 cubed gives you 216. So we're trying to make it smaller so that we can use our rules that we learned in Math 1 to simplify it. So 6 cubed gives you 216. This is power times a power, or power to a power, so what do?
Multiply.
Multiply. What's 3 times 2/3? 2. So 6 squared.
Hold up.
Where'd I lose you? Are you good? Are you sure? Speak now, forever hold your peace. Okay. So we changed 2/16 to 6/3 to try to make it smaller, because I don't know what 2/16 power 2/3 is in my head. I'm good, but I'm not that good. So I'm trying to simplify it to know something that's smaller that we'll be able to work with. So we know 6 cubed gives you 216. So let's see if we can work with that. We've got 3 to the power 2/3. Okay, this is power to a power, so you multiply. So you have 3 times 2/3 gives you 6/3, which reduces to 2. Or you could have saw that your 3's will cancel out, which leaves you with 2. What is 6 squared? That's your answer.
Okay.
It's tight work.
Huh?
It's tight work.
You should have seen the stuff that we were working on the other day.
Last week, I just used to. That's the first stuff.
This is the hardest unit that they learn. Okay. All right. Oh. Okay. Let's look at this. I'm not gonna throw you to the wolves yet by yourself, okay? I won't throw you to the wolves yet by yourself. I won't throw you to the wolves.
He said, "What the fuck am I getting now?" Somebody take you count for -3.
We use a calculator for this.
Huh?
We use a calculator for this.
We're making you do it the hard way now, so you'll appreciate that calculator later on.
I appreciate it.
Will I let you use the calculator? Yes. Why do I tell you you can use the calculator?
Because it tests this calculator.
The whole test is calculator. But I want you to understand what's going on, because literally you can type in 216 to the power 2/3 in your calculator, and it's going to say 36 immediately. Are you going to know how?
No.
No. I want you to understand the how and the why before I give you the easy way out. You've got to understand what's going on behind it. Okay? Alright. So what is the first thing that I see wrong with this problem?
Two negatives.
Negative.
Okay. Can you have a negative number? Yes.
Yes.
Yeah.
Can you have a negative exponent?
No.
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 So this negative, it doesn't matter. It can be negative all day. It's the exponent that matters. You can't have that be negative. So we're going to move it to the bottom because this is technically over 1.
Okay.
So I have 1 over negative 3,125 to the power positive 1/5. Don't forget to make that positive.
Wait, so the regular number wouldn't change when you switched it?
No.
No, it does not. A negative on the top and negative on the bottom for that does not matter. Okay. So now let's try to figure out what we're going to do to simplify it. This is what I'm going to give you a hint. Try to see if there's anything to the power 5
25.
that you'll be able to do. So some number to the power 5. Why did I choose 5? Because I want to see if I can get the 5 and the 5 to cancel out. You know what I'm saying?
Yes.
So that's an easy way to look at it, okay? Can you think of something, so what's 1 to the power 5? 1 to the power 5? 1 times 1 times 1 times 1? Oh, man.
Two.
It's 1. What's 2 to the power 5? So we got 2. Is 2 to the power anything going to give you a 5? No. Okay, so let's just scratch that one altogether. 3 won't work either. Will 4s work?
No.
Is it possible for 4s? No, it's an even number. So if you do that, you're never going to get to an odd with 4. Okay? What about 5 to the power 5?
Yeah.
That's it. Okay? So we want to do negative 5 to the power 5.
Negative. Wait, why negative 5?
Because we need a negative number. And what's a negative times a negative?
Positive.
Well, what's a positive times a negative?
Negative.
What's a negative times a positive?
Negative.
A negative, wait, what did I just say?
And
then
then
negative
negative.
So, wait, a negative times negative is positive. Positive times a negative is a negative. Negative times a negative is a, that's what I wanted. And a positive times a negative is a.
Negative.
So negative 5 times negative 5 times negative 5 times negative 5 times negative 5 will give you a negative 3,125. If it would have been 5 to the power of 5, that wouldn't have ever given you a negative, right?
Right.
But this will. So we've got negative 5 to the power of 5 to the power 1/5. What happens with this? Power times the power, so you multiply what's 5 times 1/5? 1. So it's going to cancel. What are you left with? 1 over negative 5.
Okay.
Are we good? No. Where we get lost?
We can't have a negative denominator.
You can have a negative in the denominator, but you can't have a negative for an exponent. Okay?
Yeah.
So just make sure that we remember that rule. It's fine to have a negative. Can you have negative 1/5?
Yeah.
Yeah.
That's possible all day, every day. Okay? But you cannot have a negative exponent. Got it? Okay. All right. So this one. Y'all ready to get through into the rules or not quite?
No,
Not quite.
Not quite.
not today.
Not today at all. All right. So let's try to. Can you think of anything that could be to the power 8 so I can just get 8s to cancel out for 258 or 256?
Four.
Can you think of anything to the power 8? Those are too high.
3.
Ooh, wait.
Can we go down? H to the power. H to the second. 2.
2 times 2 is 4.
Yeah.
4 times 2 is 8.
Mm-hmm.
8 times 2 is 16. 16 times 2 is 32. 32 times 2, 64. 64 times 2, 128. 128 times 2, 256.
So 8.
J to the power 8.
Oh.
2 to the power 8. And then 3 to the power 8. Because what happens? 8 and 8 will cancel, leaving you with 2 to the power 3. 2 to the power 3 is
I'm just ready to be cool with that.
Yeah, that's the hard part.
So
this is the hard part.
To find something, that's the hard part.
That is the hard part.
That's what messed me up.
They calculated score.
You can use a calculator on the
Okay,
test.
so how would you use a calculator to find what,
You would type in 256 to the power 3 eighths and it would say enter 8.
and that would be my answer?
Yup.
Why can't we do that now?
Hit math.
That's
what my mom says.
It has X to the power root. You can do any root. You can do 15 to the root. Okay. All right. Here we go. Let's keep going.
Oh,
Hold on, what?
Okay.
oh.
So look,
I need to move.
this is not going to be difficult. All right. And if it is, you didn't pay attention good enough to math 1. This is the same exact thing that you did in math 1, except instead of having whole numbers, because back then it was a to the power 2 times a to the power 4. And then you'd say 2 plus 4 is 6, your answer is a to the power 6. Now instead we've got our fractions, so it's not going to be much different. This is power times, this is a multiplication sign, so power times a power, so you do what? You add. This is a to the power 2 sevenths plus 4 sevenths. Can you reduce this to what? Do you have a negative exponent? No. Do you have any anything on the bottom of your fraction that is not a whole number?
No,
No. Do you have a complex fraction?
no.
And do you have, the index of any remaining radical is the least number possible? It is. Top on inside, bottom on outside. So this is the 7th root of 8 to the power 6. You can't simplify that anymore.
No way.
You don't have 7 eighths, bring one out. You only have 6. Okay?
Okay.
What was an easier way to do that? 6 sevenths. That's not a whole number. It's not going to be able to reduce. Alright. For this one, what's the problem that you see?
B negative.
The negative. What do you do when you have a negative? Bring it to the bottom. So 1 over b to the power 5, 6. What is the problem with this? The rule that said
Do you have anything on the denominator?
it has no exponents that are not positive integers in the denominator. Is this a positive integer? No. That's a fraction, no. It's not 1 or 2 or 3 or 4 or 5. It's not an integer, okay? So we have to make it an integer. We've got 5/6 of a b.
So do we turn it into a decimal?
Nope. Okay? So if I have 5 out of 6 pieces of the pie, how many pieces of the pie do you still need?
1.
You need 1/6 of a pie to make a whole one.
So it'd be 1B.
So what are we going to do? We're multiplying it by 1/6. That way we can make sure that we have a whole pie.
Hold up.
Do you see what I just did?
I mean, I see.
I have 5/6 of a pie, okay? So here we got our pie. I've got 5 out of 6 of those pieces of the pie. How many more pieces of pie do you need?
1.
1 more piece.
So I
to make
multiply
one full
on
pie.
both on top.
So technically, that's 1.
Because technically, remember, you don't want to multiply it by any, because we don't want to change the problem. So you want to multiply it by 1 because 1 times anything gives you itself. And b to the power 1/6 over b to the power 1/6, that's 1. So you've not changed this problem at all. We've just reconfigured how it's set up.
Okay.
Okay? So what are you left with on the bottom? We have a whole blueberry pie on the
So
bottom now.
is it B?
B, yeah.
Okay.
1 full blueberry pie, that's what you got.
1 full.
Oh yeah, because
blueberry
5
pie.
plus 1 is 6. 6 plus 6 is 1.
Banana phone
Pie
zero.
yesterday.
B to the power 1/6 from the top,
Okay.
and then you were finished.
We're done. That's it.
That's it.
Bumblebee.
Does that make sense?
I'm going to get somebody to grab my bumblebee.
You good?
Alright, is that it?
No. Do you understand what we did though? Because I want to make sure that you understand. Do you know why we multiplied it by 1/6? Do you know why it turned into B?
Actually, no.
No?
Why turn into B on box?
Yeah.
No.
Because power times power, say you add, what's 5/6 plus 1/6? 6 over 6. What's 6 over 6? 1. Good?
Yeah.
Alright.
Throw it to the wolves.
Can you try this on your own?
No.
Yeah. These
Yes.
ones aren't too bad.
Yeah, we can. We good. We good.
Try this.
We good. You gotta give us the obvious, but
I know on the first one,
It's not that bad.
there's more.
Just simplify it. So, same thing.
I have a question.
10 over 4, which reduces when you divide it by 2 to a to the power 5 over 2. You can't go any farther.
Wait, hold.
10 over 4, when you divide that by 2, because it reduces. 10/4 is a fraction, reduces.
Oh, so we reduce.
Yes, reduces to 5 halves.
Well, I got there, right? And then I did A, and then I got 1. Oh,
Is this supposed to be the hard part of this?
I see what you did, but you know. Keep it
I'm
as
not gonna lie.
simple.
yes. Don't turn it into a mixed number fraction.
Is this one?
Trying to be.
Yes.
Trying to be.
You wanna try?
I did the. Oh, I wanna do it. If you get it wrong, I got to follow up.
Is this supposed to be the hard part of this?
B's easy.
I think that the
That's
last
the only reason I
one
wanted to do
is
it.
harder.
B is easy. Which one?
Yeah.
How was it? Like, I'm so sorry. Give me some keys, we just wrote the answer.
I agree.
What is that?
I agree.
Look, but I don't have the best handwriting. And I should see it. Shut up, Dan.
You know, if you move slightly, you'll be able to see what you're writing.
Right here.
Yeah.
Well, that's not some weird page.
You know it's still recording.
Jesus Christ. Is that a 3? We have a 1/3.
Alright, so he took the 4/5 and he moved it to the bottom.
Yeah.
So 1 over b to the power 4/5. He has 4 out of 5 pieces of his pie.
Yeah.
To make a full blueberry pie, he needs 1 more piece. So he multiplied it by 1 over 5. So now we have 1 full blueberry pie, and on the top, you've got a 5th one.
Oh, that's a 5.
That's easy.
Okay, so that's b to the power 1/5 over b, and you're done. Good job.
Don't go through the rules on this one.
Don't scream. This is not as hard as it's gonna look.
Jesus.
Oh my God.
Oh, this is the one I thought it was gonna be, but this is fine.
What?
This is fine. It's not what I thought it was gonna be, but that's fine.
Okay, we're done here.
It's not
This is
even
what we're not
bad.
gonna do.
How? That's the square root of y and that's what we're top.
Oh, yeah.
It's not bad.
I give up.
It's not bad.
That's what we're not gonna do.
Okay,
Wait, I can do this.
Is the third just a regular square?
huh?
Is it like, it's just 3? There's nothing outside?
Would that
No,
be
there's
1?
nothing outside. It's a square root of 3, huh? Okay, so the first thing you have to do is you can't do anything when it's in radical form. You've got to change it to exponential form. You don't have a choice. Okay? So what is the 4th root of 27 as a radical? Or I mean as an exponent, I'm sorry. 27 to the power of 1 over 4. What is the square root of 3 as an exponent? 3 to the power of 1 over 2. Okay? Now listen,
Wait, start over. Where did we get this from?
from the first thing that we did, turning them
Yeah.
from radical to exponential form.
Oh, okay.
Remember top one inside, bottom one outside?
Yes, yes.
Okay, so the next thing, with your power rules, it only works if you have the same base.
Base.
So you can't use power over a power rule for this and do 1/4 minus 1/2. Why? Because 27 and 3 are not the same number. However, can you make 3 or any other number become 27 when you make it to the power of something?
Yes.
3 to the power of what's going to give you 27?
No.
3, right?
3. Yeah,
3 cubed.
Yeah.
3 cubed is 27. So we're going to turn 27 into 3 cubed
Okay.
and make that to the power 1/4.
I guess.
3 to the power 1/2 stays on the bottom. You have to simplify that top first. What rule are you using for the top?
Multiply.
You're You're multiplying. Power 2 of power. So what is 3 times 1/4?
You got 3 times
3/4.
Yes.
So 3 to the power 3/4 over 3 to the power 1/2. What rule is this?
Subtraction.
Subtraction is power over power, so you subtract. So you do 3 to the power 3/4
Is it 2
minus 1/2, which is what? Is what? You've got 1/4 left, so 3 to the power 1/4.
You said call that.
Change 1/2 to 2 over 4, and then you've got your 3 minus the 2. Do I need to like work that part out? How they
No,
do
that's
that?
easy. That's
No.
easy.
Just making sure.
That's easy.
Sorry. Okay, so your last step is you started in radical form, so you have to end in radical form. If you start in exponential form, you end in exponential form. So we started in radical form, so how can I change that to radical form?
It's 3 with the 4 on the outside.
The 4th root
Yeah.
of 3. That's your answer.
I just kind of did that already.
How was that?
Good.
Good?
That was hard.
That was hard. What?
Yeah. So wait, question. What about that one at the bottom? That little 3 right there. Under,
Here?
no, right here in the left corner. Oh yeah.
Wrong way.
Right there. That 3, yeah.
3 to the power 1/2 is that 3.
Wait, why did that become 1?
Because you had to change it to exponents.
So if it's just that number,
You-
we
Because there's
automatically-
imaginary 2 in
You
the thing,
have to
right?
put it, there's an
Yeah.
imaginary 2 here.
and
Because
then 1
it's
at
a
the top.
square root.
Because you gotta flip it.
Got it?
Yes.
Okay. Do you want regular wolves or not really?
Nope.
Yeah.
No.
That was some wolves come out with some sheep. People like cows.
We don't do it.
I don't know why it's not lining up right, y'all.
This guy.
It's Bob.
You watch on this.
It's bothering me because I'm telling you when I did it on my computer, I promise you it lined up.
Oh, what?
Promise.
Another name.
I don't know why it's not lining up.
Can you watch on?
Why do you always try to go to the wolves and add stuff like?
Okay.
You added some
Because I'm
wolves,
wolves.
bro. It's not even that bad.
A squeaky please.
I'm so annoyed.
So it'll be 32
Wait, you don't want to do wolves?
Do you want to be turned to wolves or you want me to go over it?
Go.
No,
Go.
don't go over, don't go over, don't go over, don't go over.
Okay, so what's the game? Explain it.
Please go.
Don't go over and here, please.
Yeah.
Just ignore me. Just
No,
ignore me.
no. Send me outside.
No.
Send me outside.
Oh, I have a point.
Send me outside.
Go outside and do
No,
it
no,
then.
catch me outside. How about that? I'll get it back.
Jesus Christ, Jesus Christ, Jesus Christ.
Good.
Alright, so this is 32 to the power 1/4 over 2 to the power 1/3. You can't use your power over power rules because, what are you doing, Mallory? You can't use your power over power rules because they're not the same thing. Can you do 2 to the power anything and get 32? Can you do 2 to the power anything and get 32?
Yeah.
I don't know.
Yeah.
What's 2 times 2?
4.
Then another 2? Another 2?
16.
Another 2?
Oh, yeah.
You got it. 2 to the power 5. Can't hear. So 2 to the power 5 gives you 32 to the power 1/4 over 2 to the power 1/3. What rule do you use on the top? You're multiplying. Power 2 of power, so you multiply. So 2 to to the power 5 over 4, and this is over 2 to the power 1/3.
Oh, then you subtract.
You use your subtraction rule because it's power over a power.
So that's 15 over 12.
2 to the power 5 over 4 minus 1/3.
4 over 12.
I'm going to go ahead and get the like denominators just so I can make sure that everybody sees it. We want to make this become 12, so you're going to have to multiply 4 by 3 to get 12 and 5 by 3 to get 15. I need to make 1/3 become 12, so you have to multiply the top by 4 and the bottom by 4, which gives you 2 to the power 11 over 12